Hello, good morning to all my students. Okay, can see me or not? Okay, so every student, can you see me? Okay, can reply me, yeah? You can see me and you can listen me or not? Okay, so from here today, I want to discuss about the practice. Okay, this one practice about okay, yes, Maxine, can listen or not? Okay, can listen or not? Why Elaine entered the class? Elaine, now is a science lesson. Okay. Okay, so now I go to can listen, so I can start my lesson. So hopefully the student finish the practice lah. Okay, so today you just for check your answer. Okay, you see your answer correct or not, and you do some corrections. So today I will discuss about the 3.1 and 3.3 and add one more. There's a tutorial. So tutorial for 3.1, hopefully you also finish lah. So that means I can share about the answer. Then for the student, if you don't have the paper, actually you can download. You can download at the description for the YouTube there. I already upload the link. Okay. So from here, we just continue the lesson. Okay, so the first one we go to discuss about the 3.1 formative practice. Okay, the first question they ask about Newton universal law of gravitation. Actually, what's the meaning? So we just transfer from the formula, become the words. So remember the formula F equal capital G, then we got 2m, is it m1, m2 over the r squared. So that means you can say the universal law of gravitational force, actually there's a directly proportional to the two body masses, okay, and also inversely proportional with the distance between the center to center two object square. Okay, so inversely proportional to the square, like you mentioned the square first, then distance between the two objects center to center. Okay, so from here I go to show. Okay, gravitational force, the meaning is between the two bodies, there's directly proportional to the products. Okay, product of the two masses, okay, of the body. After that, there's an inversely proportional to the square. Okay, square of distance between the center of the two bodies. So from here, this one is a definition for the Newton universal law of the gravitational. Okay, now number 2. Okay, we're talking about just now, there's a masses, another one is a distance, is it? So now they ask you what is the two factor, okay, the factor that will influence the magnitude of the gravitational force between the two body. So the two factor they understood lah, because G is a constant value. G is cannot change already. Either the mass or either the R, they will influence the magnetic field, is it? Sorry, gravitational force. So from here, I need to share. First one, sure, is the mass of the body. Okay, number 2, sure, is the distance between the bodies. So this one is a two factor that will affecting the gravitational force. Okay, then we go to question number 3. Okay, question number 3 is a calculations. A piece of the spec junk of the mass 24 kg is a distance 7 times 10 power of 6 meter from the center of the earth. So that means they got one piece of the object, the mass is 24. Then the distance is about 7 times 10 power of 6 from the center of the earth. So now they ask you what is the gravitational force between the space junk and also the earth. So that means we need to apply the formula. Okay, right. Let's see the info first. Okay, first one, the info, we know the mass. Number 2, we need to know the mass of the earth because they provided 5.97 times 10 power of 24. Okay, after that we got R. R is the distance between the object and the earth. Then we got gravitational constant. Okay, and the last one, they ask you what is F. Okay, what is the F? So from here, we go to show the formula first. Okay, this one is a universal gravitational force formula. So we just apply because they asked about the F, is it? So G, you just put in. Then the capital M sure is a bigger size object mass. So from here, the bigger size sure is the Earth lah, compared to the space junk. So from here, the small m is 24 kilometers. And the R, don't forget, you need to square. Okay, you press all the thing first, then you divide, then you put the bracket. Put a bracket, 7 times 10 power of 6. After that, you close your bracket, then you put square. Okay, after that, you equal, then you can get the answer. Okay, so this one is what the info you need to put in the formula. Okay, the G, capital M and small m over the distance. Then you need to square. Okay, the final answer. Okay, the dash. Okay, times 10 to the power of negative 49. Okay, so from here, we go to check, is it the answer correct or not? Okay, so this one is my force. The dash got any question or not? 3.144. Okay, power of 10 to the power of negative 49. What is that? Okay, I don't understand what is that, Divesh. Is it you give me the answer? Okay, this one is the actual answer final that. Okay. Okay, I'm going to provide the formula in the Z. Yeah, they will provide the formula. Okay, Divesh, they will provide the formula. Okay, so from here, this one, this one, the question the student, they ask about the formula or not. Yes. Okay, because this topic is too large of the formula, so we need to provide it. Okay, my same to yours. Okay, good. Okay, good, Okay, Sian, good, your answer. Okay, so this one should be the final answer for the gravitational force. Okay, so we go through to the next question. Okay, important is you remember the formula, which one you want to use lah, because normally the question, the info, they will give you full one. Okay, you need apply only. So this one topic is like this. Okay, now we go through to the next part. Okay, the next part is number 4. Okay, number 4. Number 4 is around the weather satellite. Okay, weather satellite orbit the Earth. Okay, they orbit the Earth and the height is 560 kilometer. Okay, now they got one extra info you need to know. Satellite. Okay, satellite means they are far a bit, okay, from the Earth. So that means you need to do extra one procedure. Okay, there are like thousands of formula for the physics. Yeah, memang. Okay, Divesh, we got so many formula for the physics. Okay, especially for this topic. Then after that, your new syllabus. Okay, your new syllabus, they add this one new topic. That means there are so many formula. So you must remember it lah. Okay, because the formula got relationship with the other topics. Okay, so hopefully lah, we do more than we remember lah. If you just go to memorize, actually we cannot memorize more. You must do more practice, then you know which one formula you can be applied. So this one is the reason why we need to repeat to do the exercise. Okay, number 4, you see the weather satellite. So this one, when you see the satellite, that means you must be careful because they need to add one more step. That means the radius of the Earth plus the height of the satellite. So now they tell you the height is 560 kilometer. Okay, so what is the value of the gravitational acceleration at the position of the satellite? Okay, see the question, gravitational acceleration. Now the question, they never ask about the force. So you need to recall back, what's the formula for gravitational acceleration? Okay, for the universal. This one is about the satellite. Okay, so from here, we write the info first. Every time we need to start, we need to write the info. Okay, they will show fast. They give me the answer already. So we go to check. Okay, first one, we know the H. Okay, H you want to convert to meter, then you need to 560 multiply power of 3 because you need to take out the kilometer. Okay, this one is a Earth mass. Okay, after that we got radius of the Earth. Okay, we got gravitational constant. Okay, now the question they want to find G. Okay, now we go to show the formula for G first. This one is a gravitational accelerations. So this one's only taken 1 m. Okay, the satellite, the m actually, we just ignore when you want to calculate the gravitational accelerations. They just focus to the Earth. So that means G, we get it. M, we also get it. Just the R, you need to do one more step. Okay, now we're going to show. Okay, R is equal to the capital R, that's a radius, plus H. So this one is an extra the step. So we just put in. Okay, this one is a 560, the height, times 10 power of 3, plus radius of the Earth. So I get the answer first. So first answer, I get it 6.93 times 10 power of 6. So this one is a overall the R. Okay, that means later we can apply this one answer to the small r square. Okay, now I put in all the things. Okay, G equal, okay, this one is a gravitational constant, multiply the mass of the earth, then over, just now the small r, I find it already, so I put in, okay, so I put in, then I put the square. Okay, like this is more easier for you to press your calculator. Doing together, plus the h and press together, that means later you get the answer maybe, not exactly correct. So that means you do step by step. If it was satellite, that means you need to do the first step. Okay, the first step you must finish first. Okay, after that, we go and check the answer. For the gravitational acceleration is how many? Okay, yeah, that's correct. Okay, the your answer is correct. G equal 8.292. Okay, 292. Don't forget the unit for the gravitational acceleration. That is a ms negative 2. So the answer should be correct lah, exactly 8.29. Okay, so this one's a question number 4. So that means we just try 2 questions. Suppose the question is not very hard, important, you need to know which one formula we need to apply, like this only. Okay, the info they will give all already. Okay, so we go through to the next part. Okay, question number 5. Okay, question number 5, there's a man-made satellite, also satellite. Okay, the mass is 400 kilograms. After that, they orbit the Earth. Orbit the Earth, the question never provide the height, so we just assume they are orbit surface. Okay, orbit on the surface with the radius. The straightforward to tell you the radius. Okay, the radius is a 8.2 times 10 power of 6. Okay, that means they straightforward calculate for you. Orbit the Earth, then the radius is from the Earth to the satellite already is provided. Okay, then the linear speed. Okay, they tell you the speed. Okay, 6.96 times 10 power of 3. So what is the centripetal force? Okay, centripetal force, that means you need to recall back the centripetal force. What is the formula? Okay, remember centripetal force are related with the velocity. They must have the velocity. Okay, we show the info first. Excuse me. Okay, the info, we got mass of the satellite. Okay, after that we got this one is a radius. Okay, the radius, orbit the Earth radius. After that, they got velocity. Okay, they show you the linear speed. Finally, they want centripetal force. So from here, we take out the formula for centripetal force. So this one is a centripetal force. That's the mass of the object, because now moving is who? Earth cannot move, just the satellite to move. So we need to take the mass of the satellite. Okay, this one is talking about the moving that surrounded the Earth. The Earth is a center. They just rotate at the same location. Just the satellite, they orbit the Earth and moving. So that means now the centripetal force, we must talking about the satellite, make the satellite to move it. So from here, the mass must related with the satellite. Then the centripetal velocity, this one we call linear speed, also related with the satellite. Then the R, the question already provided, so we just put in. Okay, it's the same thing. So we just put in, apply the correct formula. Okay, so anybody here can be fast, then tell me the answer. Okay, so we're going to wait. Adivesh, Silan, can get answer for this question. Yeah, I think somebody already finished about this one, is it? Okay, we're going to check the question, got provided the answer or not. Okay, yeah, Silian got. We're going to check. Yeah, 2.363 times 10 power of 3 Newton. Okay, we're going to show the calculation first. 400 multiply with the, this one is a linear speed. Then over, this one is a radius. Okay, remember centripetal force, we don't have any square for the R, only R. So the final answer, yeah, 2.363 times 10 power of 3 Newton. Okay, exactly the question, and exactly the answer. Okay, that's correct. So for the student, you did wrong. That means you better do some corrections to show how to count the answer. Okay, so from here, we go to the next part. Okay, number 6. Number 6, the figure 3.23, they show about the Mercury radius orbiting the sun. Okay, Mercury orbiting the sun. Okay, after that, they provided the radius. Okay, with the radius 5.79 times 10 power of 10. Okay, then the period of the revolutions. Okay, the question provided period. Okay, you must recall back lah. What formula got period? After that, you need to calculate the mass of the sun. Okay, remember, Siliang, this question you asked me. Okay, why the sun we need to find the mass? The mass already fixed what? Yeah, I know fixed, but the question never provided. So they want you to find out the answer. So that means you find your answer is almost same like the constant value lah. If you find out the answer is big different from the constant value, that means you're wrong already. Okay, so from here we need to find out the mass of the sun. Remember the bigger formula because so many complicated one formula. Okay, we show the info first. Okay, this one should be the info. 400 kilometers. After that, we got radius between the Mercury and also the sun. After that, we got periods. Time taken to orbit, 7.57 times 10 power 6. Gravitational constant, that's the same. Okay, last one, I want to know mass of the sun. Okay, mass of the sun. So I show you the complicated formula first. This one is a complicated formula when you want to find the mass of the sun and mass of the earth. So 4 pi square is a constant value. So the r cube is the distance between the Mercury to the sun. That one is a radius. Then we got gravitational constant, then t square. So t square is a period. Okay, the period go to oscillate. Okay, so remember you need to go to square. But now the question, you want to find the M, capital M. So everything we just apply lah. Apply, go in. Okay, don't straightforward to press your calculator and get answer. You need to do step by step. Okay, so anybody here can answer this question? Okay, we're going to check. Need some time lah because this one got complicated. You need to press your calculator, is it? Okay, be careful when you press the calculator. Okay, I showed the calculation first. Okay, 4 pi, remember, square. Okay, actually your calculator, you can press about the pi, is it? At the bottom, they got EXP. Above the EXP, they got pi. Okay, you press the shift, then you go to EXP, they produce the symbol pi. Then you put square, already is the answer. Okay, so the R cube, you also need to put a bracket. 5.79 times 10 power 10, you put cube. Okay, bracket after bracket, you put cube. Okay, so Silang, give me the answer. There's a 2 times 10 power of 30. Yeah, is it that one, the mass of the sun? So that means you can go to check lah. Is it this one? Normally the question provided. Is it the same? So it's the same. That means your final answer should be corrected. Okay, so from here I just show the answer. Yeah, that's exactly 2 times 10 power of 30 kilograms. Okay, so this one is the mass of the sun. Okay, so from here we can go to the next part, 3.1. I think just until the question number 6. So I need to go is the question, the following. There's a 3.2. Okay, now we go to the question 3.2. Okay, formative practice. There's a 3.2 about the Kleber law. Okay, Kleber law. So that means you need to know the definitions lah. Okay, for the different law, we need to know the definitions. So the first one, the Kleber law, remember, they're talking about law of the orbits. Okay, they're talking about the orbiting. So remember the sun focus point. After that, you just orbit. Okay, surrounded the sun. So from here, let's see the first law. Okay, first law is all the planet, they will move in the elliptical. Okay, the shape is an ellipse orbit with the sun at one of the focus. So that means the sun is at the one focus point, or the planet just move elliptical orbit the sun. So this one we call Kepler first law. Okay, so how about the Kepler second law? Kepler second law is talking about the area. Okay, the area from the planet to the AB, another planet from the Go to the CD. They're talking about how about the area and also the time taken when they go to move. Okay, then we're going to see the Kepler second law. A line that connected a planet to the sun. Okay, one planet to the sun that sweep out an equal area in the equal time. So remember, so you just take one of the quarter part, okay, or 1/8, something like this, or one of the quarter part, point from the planet to the sun. After that, you sweep out one of the equal area, divide it. This area and another side, you also put the same thing. Okay, actually both sides the area is equal. Okay, and also the time for the for the part you're going to move it from A to B or C to D should be the same. Okay, if you not remember, you can recall back when you see the textbook and go to recall back the video clip. Second law actually is one. Okay, this one is a definitions. Okay, so you can find out now B. Okay, this one is the sun. Okay, you can see we got X, we got Y, we got Z. Different of the planet orbiting the sun. Okay, compare the linear speed of the planet at the position X, Y, and also Z. Okay, remember the formula for the linear speed? Just now I show you. Okay, so from here we need to comparison. This one question that I give you in Google form, I think I give the wrong question because I got one question is the highest linear speed, another question is the lowest linear speed. So suppose if you want to find out the highest linear speed, excuse me, the R becomes smaller. What means for the R? R is a radius. Okay, excuse me, I drink the water first. Okay, so that means is V and also the R. R is a radius. Okay, center to center. Actually, there's an inversely proportional. Okay, we find the radius becomes shorter, the linear speed will become higher. So from here, the question wants you to compare the linear speed of the three planets. So from here, we can write, okay, Celine got question. Okay, we need to write exactly the same of the definition. Yeah, you need to write. Okay, you cannot simply go to create because the definition already is a fix. Okay, you cannot create by yourself. You need to, the keyword must there lah. Okay, example, elliptical orbits. Then after that, you must say sun at a focus. So this one is a keyword. Okay, number 2, you must talking about the area lah. Equal area and also equal time. Okay, this one is a keyword for the Kepler second law. Okay, for this one, this part for the comparison linear speed. Okay, first one, we show the formula. I need to let you to see the formula, what's the relationship. So V square equal GM over the R. R and V suppose is inversely proportional. Okay, if you want the speed become lower, that means the radius must be further. Okay, further from where? From the sun. Okay, so from here I can write the comparison. Okay, Y is the closest one. Y, the R should be the shortest. If the R becomes the shortest, sure the V is the highest. Then followed by the X, and last one is the Z, because Z is the furthest one. When it does furthest, we find it the velocity, they will drop. Okay, so during the exam, you don't write the symbol. Normally, we cannot write the symbol Y more, put a symbol more than X, more than Z. So better you write in word. Okay, you just mention the position of the Y, linear speed of the position Y is bigger than the X and also bigger than the Z. Or you just answer Z should be the lowest lah. Okay, Z linear speed should be the lowest. Okay, so you just write in the word, don't using the symbol to answer it. Okay, so we go through to the next part. Okay, third law. Okay, third law is talking about the orbits, not orbits, it's a law of the periods. Okay, they're talking the time to be orbit the sun. So from here, there's a related with the formula. Remember the formula is a t square one. The t square and also the r cube. The one is a Kepler third law. Okay, the square of the orbit periods of the planet. Okay, the square of the orbit period of the planet, that's a directly proportional to the cube of the radius of the orbit. So that means t and also r, they are directly proportional. Okay, so from here we can show the equation later. We're going to see what's the Kepler third law, the formula. Then we can show about the formula transfer become the definitions. Okay, Kepler law is straightforward to transfer become the definitions. Okay, now we're going to see this part, B. Okay, B is a height. What is the height? Should be the satellite B. If the satellite is required to orbit the Earth in 24 hours. Okay, so they ask you what's a H. Okay, remember the H. So radius of the moon is 3.83. Radius of the moon. This one is the Earth, this one is the moon. Then after that, they told you the period of the moon is 27.3 days. So that means now they got two planets. Okay, one is the Earth, another one is a moon. Okay, now they want to find out the satellite is require how many height. Okay, from the Earth after that 24. Oh, sorry, not Earth is not moving, only satellite. So from here they want to compare satellite and also the moon. Okay, the Earth is a one of the object stationary. Okay, the moon surrounded the Earth, the satellite also surrounded the Earth. So that means two object is moving. Okay, we can compare two planets. So from here they give you the time taken, that means the orbiting periods. They also give you the radius of the moon, but they never provided the radius of the satellite. Okay, so from here we need to understood is satellite, you need to add one more step. Radius of the Earth plus the H. Now the question they want to find H. So from here, we need to show about the info. Okay, first one, this one question is normally they will provide the radius of the Earth. 6.37 times 10 power 6. Okay, simply. Then after that, R1. Okay, we take the 1 is a moon. Or the 1 is a moon. So the moon is 3.83. This one's a radius. Okay, period for the moon is 27.3 days. Okay, period for the satellite, 1 day. Because they say 24 hours. So we change, become the day, more easier. Excuse me. Okay, so from here, this one actually is a Kepler third law. Okay, they never touching about the velocity. So that means they're not related with any linear speed. Okay, they just want the radius and also the periods. So from here, we just apply to calculate the radius first because you need to plus h. So this one is a radius for the satellite. Okay, radius of the Earth plus one more extra, there's a h. So later we need to minus the radius of the Earth, then you find a h lah. So from here we just show the formula. Okay, so this one should be the formula for the Kepler third law. Okay, if I'm using the one side is a t, then all is a t lah. So T1 over T2, both go to cube, go to square. Then another side is both also is a radius, R1 over R2. Then both also go to cube. Okay, now the situation what I need to find, I want to find is R. Okay, R2. I need to find R2. Okay, so I just put in all the things lah. Okay, T1 is how many? 27.3. So remember, I put the square. So 1 day I go to square also. Okay, R1 is a radius of the moon. Then I put here. Then over, don't forget, the R2 actually is a RE plus H. RE is what? Radius of the Earth. okay, plus the height of the satellite. Then you need to put cube. Okay, so all the thing I need to cross over to multiply lah. Follow your mathematics, the method. So I just cross over to multiplication. So this one when I square, there also is a 1. So I put here. So 27.3 square I put down already. So this one is a R2. So the R2 I move to the another side. Okay, now I do the calculations. This question didn't given the normally they will give one. Okay, because if they never provided Celiang, you can see from the first page. First page, they got one of the formula page. So you can refer there. Okay, if the question they never write in the question, that means you need to refer back to the formula list for the exam lah. Okay, normally the question they want you to do calculation, they must provide it because we never memorize one. Okay, we never memorize what is the radius of the Earth. Okay, so from here we just apply lah. So from here I do the calculation for this part. Okay, remember you need to cube square. This one square root, is it? Now it's a cube root. Remember cube root. So this one you take 3.83 times 10 power of 8. You go to cube first, multiply 1 over 27.3 square. Then remember you need to cube root. Excuse me. After cube root, then you get the answer is a R2, is it? So now the question actually they don't want R2, they want H only. So that means later you need to minus the H. Okay. So from here I show you the answer. Too long. This one calculation got so much. So you must be careful when you do this one. When you press calculator, you also must be careful. Okay, final answer, I get it. R2 is a 4.224 times 10 power of 7. Okay, this one is the answer after I do the calculations. After I cube root also. So from here, I just want to know what's a H. So I need to minus. Agree? So this part, power of 7, I need to minus the radius of the Earth. So the radius of the Earth is 6.37 times 10 power of 6. So I just go to minus. I find what is my H. Okay, so this one is a H for the satellite. Okay, 3.587 times 10 power of 7 meter away from the Earth. Okay, so finally I can get the answer for the height of the satellite. Okay, then the height of the satellite for the satellite, they must be there. If they want to require one round the Earth is 1 hour. So we go to count how many height the satellite must be located. If they want to orbit the Earth in one day, 24 hours. Okay, so this one should be the complicated calculations. Okay, students must be careful when they settle about the Kepler third law, because so many cubes, so many square. Okay, then this one should be the formative 3.3. Okay, man-made satellite. So the first one, they call it to do the comparison. Comparison about the geostationary and non-geostationary. Okay, remember the geostationary, they will follow this, the Earth. Okay, follow the Earth. The Earth rotate what location, they also follow. But the non-geostationary, there's not. They just personal go to rotate. Okay, they can above, they can be lower. Then they can go different location also can. This one we call geostationary. Okay, let's see the similarity. We compare them. Normally we compare the similarity and also the differences lah. Okay, first step, we see the geostationary and also non-similarity first. Okay, so first one, both also orbit around the Earth. This one is a similarity lah. I don't care you are non or you are only geostationary. You also orbit around the Earth. Okay. Okay, number 2, they will falling freely around the Earth. Okay, that means they still got gravitational force to pull it. They're still falling freely around the Earth. Okay, number 3, the motion that still obey the Kepler third law. That means the motion. Okay, the periods and also the radius, they still follow Kepler third law. That means both planets, although they are different orbiting, different location of the orbiting, but when you do the calculation, we're still using Kepler third law. Remember, the T1, T2, then you both go to square. Then equal R1 over R2, then both you go to cube. These two, they're still using this formula. Okay, and the last one, gravitational force still acting, okay, as a centripetal force. Because they can move, is it centripetal force? I mean, they're talking about the linear speed they go to moving. So from here, the gravitational force, they still act, okay, act the planet. After that, the planet can be moving by using the centripetal force. So these four things, they're still the same for the geostationary and also non-geostationary. Okay, so this one is a similarity. Okay, now we're going to see what is the differences between these two satellites. Okay, first one, we're going to see the differences, directions. Direction of the motion is the same as the direction rotation of the Earth. This one is a geostationary satellite. For the non-one that didn't follow direction, the direction of the motion that need not be the same as the direction rotation of the Earth. Okay, not exactly the same. So another one exactly the same. Okay, second differences, periods, 24 hours. That means they follow the Earth. The Earth rotate, how many? They also follow. So exactly, they will orbit 1 day, 24 hours, they will finish. So how about the non? Non, the period of the orbit can be more and also can be less. Different height, because the height is a different. Some orbit is closer, some orbit is further. So that means when they just rotate, they find the time taken should be not exactly same like the Earth. Okay, number 3, they always above the same position on the surface of the Earth. Okay, the position when they just move, they always above, but the position should be the same. Okay, how about the non? They're moving over different positions. Okay, they can below, they also can be over, more further also can. So this one, they find it, they're moving over different positions. Maybe you turn right, they turn to the left, also can. This one is a non-geostationary. Okay, so from here, need how many similarity and differences? Okay, good question from the Celia. Depends the marks. If the question give you 4 marks, they want similarity and different, both you give 2. 2 similarity, 2 differences. Okay, depends the marks. So if the question they just want similarity, then you put 4 similarity for 4 marks. Okay, so depend the marks we need to give. Okay, so this one is how we go to answer the question. Normally 1 point is 1 mark lah. Okay, so if they want 4 mark, they may at least got 4 points. Okay, so this is what we know how to answer the question structure. We need to depends the marks. Okay, then we go through to the question number 2. So from here, what's the factor to determine the linear speed of the satellite orbiting the Earth? Okay, they ask about factor, so linear speed. So we need to take out the formula for linear speed lah. Then we need to see what's the factor. So from here, I show. Okay, this one is a formula for the linear speed. What should be factor that will affect the speed? G sure constant. G is not related. We got capital M and small r. Capital M is what? Is it the satellite or the Earth? Normally, the capital M, the object is never move one. That means your satellite now is surrounding the Earth, is it? So the Earth at the center, so the M must be the big object. That's the Earth. Then the R is what? R is a distance, no? Okay, distance between the Earth center until go to the satellite, that what we call R. So from here, what will affected the linear speed? Sure, the mass of the Earth and also the distance that will affected the linear speed. So from here, we just answer mass of the Earth. The second one is the radius of orbits. Okay, the radius you go to orbit, they also will be affected the linear speed. Okay, Then we go through number 2. Number 2, they ask about the factor influence the value escape velocity. I think should be the same lah, almost the same, the formula. Because escape velocity, we just add one more, the value, there's a 2. You see the formula? Just got 1, 2 only. Okay, escape velocity, remember, they're already out from the Earth. After that, they can go to the outer space. The one we call escape velocity. Okay, they ask you what's the factor. Factor still the same now. You can see the capital M. Capital M also is the Earth. Then we got R. R also is a distance. Okay, but this one distance, we cannot say radius of the orbit. Okay, because now it's no orbit. Now they want to go further. So we're just talking about the distance between the center of the Earth and also the satellite. Okay, and also the satellite. So from here, we just answer. First one still the same, the mass of the Earth. Okay, number 2 is a distance from the center of the Earth. Okay, from the center, then you go. So I don't know how far you go. Okay, so we just mentioned distance from the center of the Earth. That one is a R. Okay, because this one not orbiting. Because this one they want to leave the Earth, overcome the gravitational potential energy. They want to go outside. So this one we call it R, is a distance from the center of the Earth. Okay, so we go through to the next. Okay, now we need to discuss whether the escape velocity from the Earth for the spacecraft X of the mass 1,500 kg is different from the spacecraft mass 2,000 kg. Is it got any differences? Okay, if the one spacecraft is a X, mass is a 1,500, another one is a mass 2,000 kg. Is it related with the escape velocity? Okay, because the question right from the planet, which one, Celiang? You ask the question number 3 or number 4? Okay, number 3 is it? So Celiang asked the question is because the question right from the planet. Oh yeah, influence the value escape velocity from the planet. Okay, escape velocity from the planet actually is this formula. Okay, this one is a formula. So that means you see the capital M only for the mass of the Earth. They're not related with any planet. So from here, they ask you the factor influence the escape velocity from the planet. So from here, the factor only is a R and also the M. Okay, so from here, you can see about the distance. The R is the distance from the center. That means the planet distance from the center of the Earth. This one is another factor lah. Okay, so have I answered your question? Okay, remember that from the planet, although there's a from the planet, actually we never take the planet mass. Okay, we just take there's a distance from the center of the Earth until you go to the distance of the planet. That one is a factor. Okay, so from here we never count about the radius lah, radius of orbit. When you say the radius of orbit, actually that's not correct. Okay, you must say the distance because there already is escape, is it? You just count as an escape distance. Okay, number 4. Okay, number 4, the question they ask about the 2 spacecraft, the mass is a different. Is it that will affect the escape velocity? Actually, the answer is no, because you see the formula, where got the small m? Okay, they're not related with the small m. They're only for the bigger m. That's the Earth, is it? So from here, your answer is no. Okay, although you are spacecraft different masses, they also not changes about the escape velocity. So from here, the answer, because the escape velocity v of the object, that does not depends on the mass of the object. So this one should be the answer lah. Although you go to change the mass of the spacecraft, actually there's not affected for the escape velocity because the mass of the Earth already big enough. Okay, then we go to question number 5. Okay, proper satellite orbit the Earth, the height is 700 kilometers. Okay, extra step you need to do because they got height. Okay, what is the linear speed of this satellite? Okay, info provided. mass of the Earth. Okay. Then after that, they got radius of the Earth. Then we got gravitational constant. Then after that, H. H is an extra because it's located above the surface of the Earth. So they ask you what is the linear speed. Okay, we take out the formula for linear speed lah. So linear speed, the formula later, we do the extra method first. Radius of the Earth plus the height. Okay, the height of the satellite. So I get it 7.07 times 10 power of 6 meter. Okay, so from here, I take out the formula for the velocity. Okay, this one we call linear speed. Okay, you can find it the square root. This one only linear speed. They never ask about escape velocity. They just say linear speed. So I just put the linear speed formula. So you need to apply all the thing in. Okay. So I just wait the answer from the student. Okay, anybody here can give me the answer? Okay, for this question. Okay, we just wait. During the chat room, I see every time just only Xi Liang talking with me. The rest, where you go already? Okay, you can show me the answer for this question. Okay, because later we still got some more. Don't forget, we still got tutorial. If the time is not enough, I think I just show the answer lah. Okay, I will show the answer. That means you just chat. So hopefully you got do lah. So that means I just show the answer. Okay, Xi Liang? This question, can you get the answer? Okay, I show in all the info first. So when I just square root, I need to put in all the info. 6.67 times 10 power negative 11. Then this one is the mass of the Earth. Then over the distance, just now I find it. Okay, so this one is the satellite distance plus radius of the Earth. Then I get the final answer. Okay, what's the final answer? Okay, 7506.98. Okay, we go to see the answer. Yeah, 7.565 times 10 power 3. Don't forget, you need ms -1. Okay, so this one's the answer when you find about the linear speed. Okay, so this one is a 3.1 tutorial from your exercise. So I just go through a very fast one because you already do. You need to check the answer only. So I go to show. First one, gravitational force. They want to find the gravitational force. So from here, you need to choose the formula for gravitational force. So we choose number 1, gravitational force. Okay, so from here, I apply all the thing I just put in. Okay, so this one is a G. Capital M is a big object. Here is a sun. What's the mass of the sun? The info already provided. Then the mass of the Earth is a small m. So R square. R square is a distance provided from the question. There's a 1.5 times 10 power of 11. Remember, go to square. Okay, final answer, I get it. 3.54 times 10 power of 22 Newton. Okay, student, you can check your answer. Okay, if you cannot, that means you record back the video. Okay, if you still don't understand, then you PM me. Okay, then we go through to the number 2. Okay, the number 2 about the 2%, 8 kilogram, both also 80 kilograms. The distance only 50 cm. Calculate the gravitational force. Again, gravitational force. So we're using first equation, gravitational force. Okay, now this all thing not related because they're talking about person, not the Earth and Sun. So from here, we just take F, G is the same, gravitational constant. Then after that is the mass different because mass is a 2%, 80 and 80. Then the distance we also follow from the question. 50 cm, help me to change, become meter. So become 0.5 lah. Then remember, go to square. Okay, final answer I get, the gravitational force very, very small. Okay, first one, your distance is closer. Okay, number 2, the mass very, very small. So you'll find it 1.71 times 10 power of negative 6 only. So the force very small. That means two person cannot attract to each other lah, because the force is too small. So from here they ask you, compare the value of the gravitational force with their weight. Okay, you see 80 kilograms. If you want to find the weight, you multiply 9.81, is it? So you multiply 9.81 already around 800. This one only how many force? So that means we find it, gravitational force is smaller than the weight. Okay, weight is a much larger, okay, compared to the gravitational force. Okay, so this one is a comparison. Okay, number 3, this one is a spacecraft. Okay, the mass is provided, then launched from the Earth to the moon. So calculate the gravitational force again. So from here, they provided is a distance. So from here, I need to show the equation, also the first one. So from I'm using this one formula. Okay, G, everybody know G is how many? Okay, capital M is what? Capital M is a bigger object. Now the bigger object should be the Earth. Okay, because they say spacecraft and also the Earth. So we take the Earth mass. Okay, number 2 is a small mass from the spacecraft. Okay, then after that, the distance they provided, then I just put in, then I go to square. Okay, final answer, the force is a 8.3375 Newton. Okay, so this one is a gravitational force. Okay, number 4. Okay, what is the height from the surface of the Earth if the value gravitational force is 1/3 from the surface of the Earth? So that means they say if I want to get the gravitational force is 3 times smaller than the Earth, what is the location I need to locate it? Okay, that means you further lah. You further, you find your gravitational force become less, is it? Now I want to less how many? 3 times smaller than the Earth. So Earth is how many? Earth is 9.81, is it? So I want 3 times smaller. So from here, I need to show first. Okay, I need to find second equation because they want to find, they want to find the gravitational force also, but I need to find out what is the gravitational for the Earth first. So I'm using the equation, this one first. Radius equal to the 6.37 times 10 power of 6 plus h. This one is a h location. We do know what is your location. So later we need to find this one h. So I need to show this one first lah. 1/3 multiply the force. Gravitational from the Earth is how many? 9.81. So that means later the object, they further from the surface, they only got the gravitational force 3.27. They want 3.27. Okay, only. So from here, I need to apply the equation. This one. Gravitational acceleration later only 3.27. Because I want you 3 times smaller than the Earth. So I count, so I get 3.27. So from here, I need to find is this one r square. This one r square is how many? This one r square actually is this one. I show already the calculation. You need to plus the gradient of the Earth and also the h. Then you go to square. This one we call r square. Okay, now I need to show the calculation. Okay, 6.67. This one is a gravitational constant. Okay, M, capital M. This one is a Earth mass. So R square means this part. Why not force but accelerations? Okay, because the question they want to find H. Okay, they want to find H because they told you the info is a gravitational force is 1/3 from the surface of the Earth. So we know our Earth, the force is how many? 9.81. Okay, gravitational force to pull, there's a 9.81. That's a gravity lah. Okay, 9.81. So that means 9.81 already is a gravitational force to pull it. So that means we need to find out if you further from the Earth, actually your gravitational is how many? So we get it like this lah. Okay, so that means you need to remember gravitational force pull for the Earth, the same as the gravity we pull it. Okay, that's around 9.81 the force to pull it. So from here we get it, there's a 1/3 from the Earth. Okay, so wait. So this one I will discuss again for you. So you see this one part first. Okay, the height, they ask if the value of gravitational force is 1 over 3 from the surface of the Earth. Okay, so if you want to find the gravitational force, then you need to find out the formula, is it? So G equal mm, after that over the r square, is it? So if you're using that formula to find out, actually you get the answer should be 9.81. That's a 9.81, exactly the same. So from here, we need to know there's a 1 over 3 smaller than the Earth. So that means we know the gravitational force also is a smaller part from the Earth. Okay, so this one, we just skip a while because I need to do again the calculations. Because just now the CLM, they asked me why acceleration not about the gravitational force. So I need to prove. Is it the answer is the same or not. So we just skip this one question first. So later I will give you the actual answer. Okay, we skip, we go to number 4 first, number 5 first. Okay, number 5 first. Okay, the communication for the satellite. Their mass is 80 kg. They're orbiting the Earth. The height is 1.5 times 10 power of 6 from the surface of the Earth. Calculate the gravitational acceleration of the object. Okay, this one memang is a gravitational acceleration. So I put this one formula. So I just need to add one more thing because they say the height is 1.5 times 10 power of 6. So I add the R already, so I can straightforward to get the answer. Okay, so put the G, put the M. M is what? The mass of the Earth. Then over the R. So actual answer 6.46. Okay, MS negative 2. Okay, later the question number 4, I will show you again actual answer. Okay, number 5, plot the graph. I think this one everybody know. We plot the graph for the G against the R from the center of the Earth to infinity. So suppose the graph become like this lah. Then in the still in the Earth, the graph becomes straight. After the surface of the Earth, you find it, they will inversely proportional. Okay, number 7, calculate the gravitational acceleration still using the second equation for the surface of the moon. Okay, surface of the moon. So from here, we're just using this formula for the moon. So we take everything from the moon. So from here, 6.67, then the moon is how many? So we take the moon, then over the radius of the moon. So if they ask about the Earth, then you find the Earth lah. If you find the moon, then you're using the moon. So I get the answer 1.618. Okay, then we go to the number 8. Gravitational for the Earth is a 10. The mass of the Earth is a m. Radius is a r. Calculate the gravitational acceleration. Still the same formula. Okay, so from here, G equal capital GM over the r square. So this one, they say the point is a 3r. Okay, the S already distant 3r above the surface. So the r become increasing. The r increasing, understood, G will drop lah. But drop how many? Then we need to show. Okay, this one they told you there's a 10. Gravitational is a 10. So from here, I need to show. If I'm using G prime means the for the point X lah. For the point X, the gravity is how many? So from here, we just GM over R plus 3R square. You need to plus another 3R because the point is 3R away from the surface. So you put square. Okay, I continue to R plus 3R become 4R. So for R square already, I think the time is finished already. Wait, I just a while. Then I continue. So this one GM over the 16 square. Can you see 16 square? Because the square I put in 16R square. I put the 2 go in already. So this one 4 square becomes 16. So now the situation for the new gravity is how many? New gravity already is a 16R square. So you are how many smaller? You are 1 over 16 smaller than the 10 ms negative 2 because you are 3r. Okay, although you are 3r, don't forget we got square. Okay, your 3r plus another r is from the radius of the Earth. Okay, radius of the Earth plus 3r far away. So total got 4r lah. So don't forget you got square. After square, it becomes 16. So final answer, your G prime is how many? G prime now is a 1 over 16 multiplied the 10. Okay, this one is a new gravity for the point X. Okay, so the final answer, you only got 0.625 ms negative 2. Okay, this one is a gravitational acceleration for the point S. Okay, 9. This one is asking about the speed. Okay, speed, we're using the linear speed formula. Okay, so from here, linear speed formula for the satellite to orbit. So they tell you the height, 300 kilometers. So that means you need to do the extra step lah. Okay, I do the extra step. So from here, the R. Okay, don't forget the R. You see 6.37, that's the radius of the Earth. They plus the height. Okay, after that at the top is a G and also the M. M is the mass of the Earth. So after that I square root, I get my answer. 7.746 times 10 power of 3. So this one is a linear speed for question number 1. Okay, how about the orbiting? Okay, the orbiting. Okay, let's see the orbiting. Okay, now we're going to see the orbiting. Okay, orbiting is the satellite speed we finish. Then the orbiting, that means we need to using the formula to find the T. Remember the T? Okay, the T, we get it from the last formula. The last formula is the biggest one. Just now I told you the complicated one. So from here we got T, is it? Only this formula got T. So I need to form this one formula to take out the periods. So this one is a M 4 pi square R cubed over GT squared. So I want to take out the T squared. So they become T squared equal 4 pi square R cubed over GM. Okay, everything put in. So put in. Then this one is a distance R, the distance for the Earth, the distance from the radius of the Earth, is it? Then they need to plus some more. Okay, then after that, the bottom is a GM. Okay, I think I need to show something. This one is a 4 pi square. Then the R cube. R is what? R is the radius of the Earth plus 300 kilometers. Okay, I skipped the step already. So after you plus, you get it, there's a 6.67. Okay, remember this one plus H, you need to do the extra step. 300 kilometers plus the radius of the Earth. Then you over the G over the mass of the Earth. After that, you get T. You need to square root. Okay, after square root, then you get the period is the 5.409 times 10 power of 3 seconds. Okay, so this one is the extra the step you need to do because this one is a complicated formula. Okay, I will recall back for question 4 later. Okay, so this one they already finished 3.1 for the student. If you don't have this paper, actually I upload for you already. If you don't have, that means you can go here, the link here, and scan the barcode. You can get the question. Then you can recall back the question. Okay, so from here we just finish here. Okay, don't forget I got send you 2 things. One is a Google form. Okay, Google form, you need to complete it as a PBD marks. They got 10 questions. Okay, one more is your Google Classroom. I share for you already. That one is one of the structure question. Okay, this one structure question, I want to test about PBD for 3.3 man-made satellite. After finish, you need to turn in the Google form. Due date is tomorrow 5 p.m. Due date is tomorrow 5 p.m. That means after 5 p.m. I never count about your marks. Okay, that one is what you need to do for the Google Classroom. Snap photo, then turn in. Okay, or you can straightforward to write in the paper, is up to you. Depends your technology for the your handphone or using your laptop lah. Somebody that can write. Okay, then after that you turn in. Remember the time is tomorrow 5 p.m. Okay, one more your Google form. Google form got code. Okay, they got one of the code. Okay, Silang, you help me to type ellipse. ELLIPSE PSE, capital letter. Okay, after that you put 2021. That one is a code. Ellipse, capital letter ELLIPSE. ELLIPSE, then 2021. Okay, you can have to type that, but the student don't copy paste. Don't copy paste. They just you need to see from here, then you need to retyping into the Google form. Okay, one more thing, Google form only using MOE mail. Don't using Gmail. Okay, because we find that got other student do know from where one they hack in the Google form. They're using other mail. So I log already. I just let the Gmail, let the MOE mail student to log in only. Okay, when you just log in, remember you are using the school one, the government one, the email address. Okay, so our lesson just until here. So hope the student can be understand and check the answer and do the corrections. That one is important. Okay, just thank you for your watching. Okay, bye.